this is section 3.9, problem 16. Alright. So we have our light here, and that's our building. The building is there, and the person's shadow. The light is 12 meters away from the building. Right. And the person standing between the building and the light on the ground. The person's height is 2 meters. So I'm going to call the distance from the light to the person x. Okay. Alright, so, and the height of the person's shadow on the wall is, I'm going to call y. Alright, so the distance from the person to the building or the wall is 12 minus x. Alright. So we're given that dx dt is 1.6 meters per second. Okay, that's how fast the person is walking away from the light. We're also given, no, that's all we're given. And we're asked to find dy dt when x is equal to 8. Okay. So to get our equation, we're going to use simple triangles. Alright, so from the bigger triangle, which is, we have that y is equal, or y over 12. That's the ratio between the ratio of the person's shadow at the wall and the distance away, the distance of the light from the wall. Okay, so that ratio is equal to the height of the person over the distance x the person is from the light. Alright. So if you solve for y there, you get 24 over x. Alright, so that's your equation for y. So find, the next thing to do is find dy dt. Okay, and to do that we're going to differentiate implicitly. Okay, so that's dy dt is equal to to differentiate this, I'm going to use the quotient rule. That's x squared, x times 0, 24, 0 minus x times 24, right? All of that times dx dt, right? Because I'm differentiating implicitly. So if you simplify that, you get negative 24 oh sorry, so this should be, so right, it should be 1 times 24, because the derivative of x is 1, right? Alright. So you got negative 24 over x squared dx dt. Alright, so now you know dx dt, which is 1.6. You know we want to find dy dt when x is 8. So we just plug that into the equation we have right there. So plug dx dt and x is equal to 8. Alright. So this is 39a. So we have a fisherman sitting on right, so somebody's fishing on top here, right there. Right, and the length of his fishing reel is R. I'm going to call that R. And the distance from where the person is sitting to where his reel hits the water is X. It's like it's frozen. No, wait, it's going. Alright, sorry about okay. So we're given that dr dt here is negative 2 meters per second, and we want dx dt when r is 50 meters. Alright, so from our equation, or to get our equation, we use the Pythagorean theorem. So from Pythagorean theorem, right? It's because we have a right triangle, right? So you get that x squared plus 30 squared is equal to r squared. Alright. So to differentiate that with respect to t, right? Using implicit we get 2x dx dt plus 0, right, is equal to 2r dr dt. Okay. So dx dt is equal to r over x dr dt. Okay. So we know everything, but we know r, we don't know x, we know dr dt. So to get x, at r is equal to 50, we solve this equation. X squared plus is equal to 50 squared minus 30 squared, and we get that from the equation we derived earlier on. Alright, so solve for x here. Right, and plug x, r, and dr dt into to get dx dt. Okay.